What are waves? Before we answer that question, let's ask a few more. We have a red ball right over here tapping on the surface of the water. And that's all that. And you have this little mechanism here that's moving it up and down. It creates waves along the water surface. What do you notice about the movement of the water? In what direction is the wave moving? And what happens to the height of the water in the up and down direction here over time? Please go to the next slide to check your answers. The water seems to move outward, right? You can see these waves going out like this. But if you put a little piece of styrofoam right here, it would not be moving in this direction. It would just be going up and down. And that's the exact same thing that this ball is doing. It's going up and down. So if I put little pieces of styrofoam, they'll do the same. So what direction is the wave moving? Well, the wave is moving out and away from the red dot. And what happens to the height of the water over time? And you can get that by looking at a little piece of styrofoam ball there. And you'll see that the water height goes up and down. That height decreases the farther away you get. So right over here, the water is going up and down pretty much. Out here, it's not going up and down as much. When the water is undisturbed, it is found at its equilibrium or rest position. So here we have a very calm lake, and the water is not going up or down at all. We call that equilibrium. So how do these waves form? Well, what are waves doing? They are creating an oscillation or a vibration in the space or matter they travel through. That means it goes up and down, it's vibrating. This wave starts when the water particles are disturbed, and the wave moves away from the source, and the source is that little red ball. The wave moves outward in all directions, and the surface of the water is oscillating, and it's vibrating up and down, up and down. That's the oscillation. Let's distinguish between a pulse and a wave. A pulse is a single disturbance that moves outward. So the person here puts their finger down into the water and pulls it up, and one wave comes out, and that wave is going to keep moving in that direction. A wave is a series of pulses that produces repeating and periodic disturbances in the medium. So here you just have the one pulse going out. Here you have a number of pulses going out, and you just have these patterns of waves here. They keep moving out, and they periodically go up and down. It's hard to see this, so please click on this video to see pulses and waves. Another definition. Mechanical waves are waves that travel through matter. Could probably also call them matter waves, but we'll call them mechanical waves. The type of matter that the wave travels through is called a medium. A medium can be any solid, liquid, or gas. So, a couple questions. What medium is this wave traveling through? And what are some other media that waves can travel through? And we already said solid, liquid, or gas. Please go to the next slide to check your answer. For this example, the wave is traveling through the water. Other mediums, it can travel through air, which is a gas, but we counted it again, rocks, steel rails, string, anything that will support an oscillation. To better visualize what's going on, please click over here, and you'll see a simulation of waves. These are provided by the University of Chicago at Boulder, their interactive simulations project, and it's a bunch of labs which are pretty neat. So on this one, experiment with different ways to start a wave. Then decrease the damping and observe what happens to the motion of the waves. And finally, observe the movement of the green beads in the rope, and that will make more sense when you click on the lab here and try it. Here is a very important point. Waves transfer energy, not matter. What does that mean? Well, before we look at the picture, remember earlier we talked about that little piece of styrofoam in the water? The waves were moving out from the disturbance all around the water there. The styrofoam just went up and down. It didn't move laterally or horizontally. So something was being transferred, but the water was actually just going up and down. So let's see what that means here. As a wave moves through a medium, in that case the water, and we'll call that the x direction. And in that example we had earlier, that's the horizontal surface of the water. The wave carries energy, and causes the particles in the medium to vibrate around their rest position. That just means they're going up and down. So, earlier that was the styrofoam going up and down, so please view that blue, red, green thing as a little piece of styrofoam that's just going up and down. The wave are the wavy lines, and they're moving in the x direction. When the wave passes, the particle returns to their rest position. Waves can carry a large amount of energy, like a tsunami in the ocean. So please look at that picture again. Focus on the green line, which is going up and down. Sure looks like that wave is moving, and it's kind of an optical illusion. Looks like it goes left to right, but you may see it going right to left. What happens to that green dot, which is the same position on the wave? It stays in one place in the x direction, but goes up and down in the y. That's why if you're in the water at the ocean, a wave comes by and you're just kind of vertical in the ocean, you just go up and down. You really don't get pushed to the shore. Well, you do, but that's other wave functions going on. You're just bobbing up and down while the energy of the wave moves from the ocean to the shore. The oval shapes, which is that bit of styrofoam, it's not moving horizontally, but it's moving vertically as the waves move through. If there were no waves, the ovals, or the bits of styrofoam, would stay on the gray line. That means y is equal to 0, and they're not going up or down. The name of this type of wave, and there'll be another wave we'll cover a little later, it's a transverse wave. That means the particles in the transverse wave, think of the water particles and also that bit of styrofoam, they vibrate or oscillate or move up and down at right angles to the direction of energy movement. If the energy is moving left or right, the particles are moving up and down. So we have the energy being transferred by the curvy lines, the wavy lines, and they're going this way. But what are the individual particles doing? They're going up and down. That's perpendicular, right? That's a 90-degree angle there. So we call that a transverse wave.